Welcome everyone to this topic of significant figures. When you are learning chemistry, it is all about math which is used in chemistry. Now sigfigs or significant figures is also a part of physics curriculum. So if you are a physics student or chemistry student, this will help you. Or if you are a prospective physics or chemistry student, this is something that you should not miss. So significant figures are the figures in the measurements which will determine the precision of a measurement. There are some rules that are applied to give your answers in the correct number of significant figures. Okay, so what do you mean by that? We are going to look at the digits which actually matter in a measurement. So let us see which digits in a measurement are significant. Now all the non-zero digits are significant. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. All these digits are significant in the measurement. Now if there are zeros in between these non-zero digits, that is if I have 1, 0, 1, 1, 0, 5, 4, 4, 0, 8. So that 0 which is sandwiched between two non-zero digits are also significant. Now you may wonder, what is she talking? I'm not understanding. Don't worry, we are going to look at all of this with examples. Now leading zeros, that is the zeros which are in the beginning of the measurement, they are called as left end zeros, are significant. So whatever zeros are in the beginning of the measurement are never significant. So if you have like 0.0005, all the zeros which are at the left end are not significant. Now the trailing zeros mean zeros which are at the end of the measurement. Now the trailing zeros are significant only if there is a decimal place. Once again, the zeros on the right side are called as trailing zeros. The zeros are towards the end of the measurement are trailing zeros. They are significant only if there is a decimal in that measurement. Otherwise, they are not significant. Now you may wonder why certain digits are significant and certain digits are not significant. Now there is a reason behind that, but right now in this particular video, we are looking at the rules for determining the significant figures. And why they are called as significant digits, that's a separate conversation. We will have it in the separate video. So look at these examples and we are going to apply those rules in these examples. 4, 5, 6. So 4, 5, 6 means this measurement has only non-zero digits. So all the three digits are significant. So therefore we will say there are three sigfigs. There's three significant digits or three significant figures in this measurement. Now let's talk about the significant figures in the second measurement. We have 0.00450. I told you all the zeros on the left are called as leading zeros or left end zeros and they are never significant. Okay, so in that case 4, 5 is definitely significant, but what about the 0? Now we know the rule, that is the 0 on the right side are significant if there is a decimal in the measurement. So since there is a decimal in this measurement, this 0 on the right side becomes significant. So there are three significant figures or three significant digits in this measurement. Now comes 205. Now 205, this 0 is between two non-zero digits, means 2 is also significant, this 0 is also significant and 5 is also significant. So we have three significant digits or three sigfigs in this. 700. I told you the zeros on the right are also called as the trailing zeros. The zeros towards the end are not significant if there is no decimal in it. So since there is no decimal in this, the only 7, that is the first digit, is only significant. So we'll say this has only one sigfig. Okay. Coming to the last measurement, we have 3090. So once again, left end zeros are not significant. Right end zeros are significant. Also the 0 between the two digits are significant. So all these four digits are significant. Now you directly have such question. They'll give you these digits or these measurements and they'll ask you to find out which digits are significant or how many significant figures are there in this measurement. Okay, so this is about how many sigfigs, and we applied the rules that we learned some time back into this. I would also want to go back to the rules and I would like you guys to take the screenshot of these rules. Okay, if you can write them, great. Okay, now let's look at this as the question, and these are the answers of those questions. Okay, now this is about the significant figures. Using significant figures, sometimes you have to do something called as approximation or rounding off. Now when you're rounding off a number, what is it that you will pay attention? Just one thing. When you're going to round off a particular number to the number of digits that is mentioned in the question, you will have to drop certain numbers at the end. Okay, example, suppose I have the digits in my measurement are 14.36. Okay, let me make it a little bigger. So these are the digits in my measurement. Okay, now let us say the teacher asks me, or I am supposed to submit this answer in only 3 significant figures. So 3 significant figures means I have to drop this last digit, correct? Because there are 4 significant figures here and I have to submit my answer in 3 significant figures, means this has to go. Now if this goes, we have to understand that this 6, okay, when it is going, since this number is almost close to 14.40, right? Because 36 is close to 40. Suppose it was 31, then we'll say, okay, this is closer to 14.3. But if I say 14.37, 36, 38, 39, it's close to 14.40. So when we drop this, what we do is we add a digit to add 1 to 3. So it's going to be 14.4. Okay, so this is how you will round off. Now rounding off is having some other rounding off topic will have some other rules also. Let's quickly look at some examples to understand the rules. Okay, so 6.786. Now we have to round off till 2 decimal places. 2 decimal places, or sometimes they may ask you to round off to some significant figures. So here it is 2 decimal places. So I want only 2 places after the decimal. So 6, the last digit has to go. So if this digit is more than 5, then we will up the previous digit. So we'll write it as 6.79. Easy, right? 98.449. I want till 2 decimal places. So again, 4 has after 4 there is 9. This 9 has to go. Since this 9 is more than 5, I will write this as 98.45. 0.004567. I want this till 3 sig figs. Students, remember, significant figures, the left end zeros are never significant. So the 3 significant figures would be 4, 5, 6. So the 7 digit that is there, the last digit has to go. So this 7, if I remove this 7, I cannot remove it like that. I have to add 1 to the previous number. So it's going to be 0.00457, because 6 plus 1 is 7. Now 5.949. 5.949 till 3 significant figures again. The last 9 has to go. So this 9 is more than 5. So I'll add 1 to the previous digit. So then the final answer after rounding off is 5.95. So this was about rounding off. Students, I understand this seems to be very easy. But when you have these numerical questions and you have answered them correctly, you have done all the calculations correctly, but if you don't submit it as per the instruction, that is the requirement, which is about some significant figures or rounded off or approximated to some number of decimal places, you will get the entire answer wrong. Okay, so it's very, very important that we are super clear about these concepts. Now coming up next is fundamental operations and significant figures. Now let's apply the knowledge of significant figures and approximation to solving questions where we are adding, subtracting, multiplying or dividing the measurements. So the first thing is, when you add or subtract the measurements, what is the rule? So the rule is, when you're adding or subtracting the measurements, you have to look at the measurement with least number of decimal places and submit your answer with least number of decimal places. So 12.11 and 3.2, you'll realize that 3.2 has only 1 decimal place, 12.11 has 2 decimal places. When you add, you get your answer as 15.32. But when you submit, it will be incorrect if you write 15.32. Your correct answer is going to only till 1 decimal place. Students, all that I'm explaining, there are some reasons why we are doing this. But right now, if we know the rules and we can apply those rules and get the correct answer, that is what is important. Okay. When you come into my online coaching where I meet you in person, I can definitely explain the reason behind this. Right? Okay. Now 4.001 minus 2.11. If you subtract this, my dear students, your answer is going to be like this. But again, as I said, the rule is that you have to submit your answer with the decimal places which are present in the least number of decimal places present in any of the measurement. So in the first 4.001, there are 3 decimal places. In 2.11, there are 2 decimal places. So answer should be only till 2 decimal places. So if I approximate this, if I'm taking away the last digit, because it is less than 5, I can simply ignore it. Yeah. Now, coming to these 3 digits, these 3 measurements that I'm adding, 7.03, 2.1 and 0.002. If I add all of this, actual answer is going to be 9.132. But can you see that there is only 1 decimal place in this 2.1? So the least number of decimal places is 1. The first measurement has 2 less decimal places, the second one has 1, and the last one is 3 decimal places. According to the rule, we have submit the answer only till 1 decimal place. So we have to take away the 2 and 3 both. So we are just going to look at this number, which is immediately after the first decimal place. Okay, so I have to submit the answer only till first decimal place. So to take away that, this 3 is less than 5. So I'm going to simply remove everything that is after 3 and write nothing. We are not going to add any number to 1 because those digits, the digit immediately after 1 is less than 5. So you don't have to look at the digits after, the whole chain of digits. You have to only see the digit immediately after the digit that you want to approximate to. So here we want to approximate till only 1 decimal place. So I saw that after 1 there is 3. So I just remove 2, 3, everything that is there after 3. So this is about the rounding off when you are adding and subtracting the measurements. Now what happens when you're multiplying or dividing? In multiplication and division, students, you have to give your answer in the least number of sig figs. Remember, for addition subtraction, it's least number of decimal places, and this is least number of sig figs. If you want, please take a screenshot of this and also write it in your notebook. So whenever you are adding or subtracting measurements, it will be least number of decimal places. So add and subtract together, write the answer in least number of decimal places. Multiplication division is least number of sig figs. Let's look at some examples. So 4.56 and 1.4. So let me calculate. If it is 4.56 and 1. You can also do that. Let's see what's the answer that is thrown to us. So 4.56 times 1.4, the answer is going to be 6.384, right? So the answer is 6.384. But as I told you that it will be incorrect if you give the answer in the wrong number of digits. So what we do is we are going to now approximate. How do we approximate? We approximate by considering the least number of sig figs. So if you will see in 4.56, there are 3 sig figs. In 1.4, there are 2 sig figs. So answer should go in 2 sig figs. So to remove the other digits after 3, we have 8. So we know that 8 is more than 5. So we just add 1 to this digit and we remove everything else. Okay. So this is how it goes. We keep this here. So final answer is going to be 6.4. Now let us see the division. 2.11 divided by 3.2. So if you do 2.11 divided by 3.2, your answer comes to 0. Oh, sorry, my bad. It's 12.11. 12.11 divided by 3.2. Please divide for yourself also and see what's the answer. So the answer we get is a long answer. It is 3.784375. Okay. Now this number is so big. But what is the appropriate number of sig figs, my dear students? You know that 12.11 has 4 sig figs, 3.2 has 2 sig figs. So answer should be only till 2 sig figs. So the 2 sig figs end here. So after 7, there is a digit which is more than 5. So we remove everything here and just add 1 to the 7, and therefore the answer is going to be 3.8. Okay. Let's look at the next one, students. All right. Okay. So 0.0, now let me multiply this, 0.0090 times 5.33. And the answer is 0.4797. Okay, so it's 0.4797. Now again here, the least number of sig figs will be 0.4797. The first one on the left has only 2 sig figs because I told you left hand zeros are never significant. Right hand zeros are significant if there is a decimal place in the measurement. So that way 90 has 2 sig figs, 5.33 has 3 sig figs. So our answer has to be submitted in 2 sig figs. Therefore, I have to remove everything after 7. And since the digit immediately after 7 here is more than 5, we'll have to, when we remove this, we'll have to add 1 to 7. So therefore, the answer is going to be, oh my bad, this is going to be 0.004797. I'm sure you also got that. Yeah. So if you have done it, you must have got this, and we have to remove these 2 digits. We'll add 1 to 7, and therefore our answer is 0.048. So this is about what to do when you have to submit your answer after doing fundamental operations on the measurement. So that's all for today. Thank you so much. And this whole video is very important throughout your chemistry honors or regular chemistry or AP chemistry year, because if you know the concepts, you've done the correct operation, but if you've not submitted the answer, the correct number of sig figs or correct number of decimal places, you will get your entire answer wrong. Okay, and students have been, very, very disheartened when they get their marks if they don't follow these rules. So once again, if there is anything that you want to watch, you can go back, watch that segment, do the examples, and I'm going to see you in the next video where we'll talk about some more complicated concepts of chemistry honors and regular and AP chemistry. That's all for today. This is Darshana Phalke, founder of Chemistry Express, signing off.